Let's get into talking about the real basics, and then we'll get our hands on the ultrasound machines and start to use them properly. Knobology is a great name for a study of knobs, I guess. The knobs on most ultrasound machines are fairly similar, even though every ultrasound machine is going to be a little bit different. And we'll go through the ones that are really important for us to know as physios and for setting up our patient. So if we zoom in on this, the first thing we'll have a look at on this unit, the patient button is up in this corner. The patient button is going to give us the ability to input all of the data about the patient, their name, their date of birth, what type of exam it is. And this is really useful for going back and doing your notes and exporting your images to your patient notes as well. So we'll have a look at setting up a patient in a moment. The next button we'll have a look at is the depth. Now, these units that we're using today have an automatic focus, and that's important because the slice thickness of the ultrasound, even though we get a perfect two-dimensional image, it's actually three-dimensional. So if we've got an ultrasound head and the sound waves are converging like that, they're going to have a focus point, but our units use automatic focus. So the only thing that's important to know about that is, if we have the depth set too deep, we might not get the focus in the right position. If we have the depth set too shallow, again, you might not get the focus in the right position, or you might not even be able to image what you're looking at. So we'll have a look at adjusting the depth to get the optimum image. Here we have the gain, and the gain is essentially going to turn up our brightness. So it's going to increase the amplitude of the echoes, or increase the amplitude of the sound wave. And that can, again, be useful. If you turn it up too much, you're going to get a washed out looking image. If it's not bright enough, you're not going to be able to visualise the images or the structures that you want to. Now, these knobs are called time gain compensation or time gain control. And you see how they're basically lined up. This is the superficial structures, this is the deep structures. What this does is it increases the amplitude again of the echoes at the level of that particular bar. So again, important to know, because attenuation means that the sound waves coming from deeper are going to be washed out or are going to be weaker. And if we can turn up the intensity of the lower areas of the image, it's going to help us to get a nice, even, clear image. In terms of frequency, with ultrasound, the higher the frequency, the clearer or more defined the image. So the higher the frequency, the greater the ability to see two very small points which are close together and to differentiate between them. However, when you increase the frequency like that, you lose more in terms of power. So the higher the frequency, better definition, but the weaker the ultrasound. So it's not going to be able to penetrate as deeply. If, however, you turn down the frequency so that you're getting a stronger image or a deeper penetration, if you like, you may miss out on a little bit of definition. So ideally, you want to have the highest frequency you can and still be able to visualise the structure. The freeze button is really useful for when you get an image that you want. You hit the freeze button and you can zoom back in and out of the particular frame that you'd like to get. And of course, save is very self-explanatory. So we do want to be saving images. We want to have something that's concrete, something that's objective, something we can go back to our patients with and say, hey, this is where you were on this day and this is where you are today. Because patients absolutely love those numbers, don't they? In terms of probes, all of these units have two probes. The linear probe on our units are the high frequency probes. So we use these for our small parts. We're going to use the linear probes for our shoulders later. They all have presets when you hit the probe button, so you can choose between your small part, you can choose between your abdominal exam. Some of them have an orthopedic setting. And our convex probes, on the other hand, are our lower frequency, higher penetration probes. So we use them for the abdomen and pelvic floor. In terms of the modes, B mode stands for brightness mode, and that's the standard image in real-time ultrasound that we're used to seeing. B plus M we're going to use for its brightness plus movement, and we're going to use that for the diaphragm later, so we can see the movement of the diaphragm while we're doing some real-time ultrasound. And that, I think, is very interesting, but also gives the patient some feedback about the smoothness of the contraction, the length of the contraction, and the amplitude of the contraction also. And then 2B and 4B are just side by side B mode images. Down here we've got our trackball, measure button, clear button. If again you really want to, and we'll do this in a practical in a moment, if you really want to have a look and save these images to your patient files, it is worth putting a body mark on the image so you can standardise where you have your probe. and where you had, or what part of the patient's body you were looking at. Now these two buttons, not on every unit, but the Q optimization and the tissue harmonic imaging, they're just preset buttons, preset image optimization that the manufacturer puts in. Every machine is going to have slightly different ones, but they basically tidy up the image for soft tissue. Okay.